Okay, good. So now we're going to test that out, of course. This whole implementation is over because all the rest comes from our different templates, the data preprocessing template, the data preprocessing toolkit, and the logistic regression implementation, for the rest. So now we can just run the whole code and see what happens in the end. So basically, we are ready to run this code, but before, let's not forget to upload the dataset inside this notebook. So let's click this upload button. Then please find your machine learning A to Z folder on your machine, wherever you downloaded it. And then let's go inside part 9, dimensionality reduction, then principal component analysis, then Python. And there we go. Let's take our wine dataset, click open and click OK. And now you're ready to run this implementation with a simple run all. So let's click runtime here. And are you ready? Let's do this in 3, 2, 1, go. Run all. All right, importing the libraries and importing the dataset, all applying the data preprocessing phase, then applying PCA. Well, it goes way faster than me. And what do we end up with? Well, we actually end up with an amazing accuracy of 97%. So this business owner, of this wine shop definitely had a great intuition with this idea of applying dimensionality reduction. Because dimensionality reduction doesn't only consist of reducing the complexity of your dataset, it can also improve the final results, by combining dimensionality reduction and your predictive model. And here, this is exactly what happened. We get an amazing accuracy of 97% with actually only one incorrect prediction. Right? And here, by the way, this is interesting. This is the first time you see a confusion matrix of 3 rows and 3 columns. And that's, of course, this time we have 3 classes, right? We have 3 customer segments, 1, 2, and 3. And therefore, we have 3 classes to predict. And so this is the number of correct predictions of customer segment 1. This is the number of correct predictions of customer segment 2. This is the number of correct predictions of customer segment 3. And this is the number of incorrect predictions of customer segment 1. Right? So anyway, only one incorrect prediction in total, and that's why we end up with such a great accuracy. And so now we should see amazing results on the graphs, first with visualizing the training set results. And indeed, these are our 2 principal components, PC1 on the x-axis and PC2 on the y-axis. And then these are, the different prediction regions. This is the prediction region of class number 3, where each wine of which the extracted coordinates of PC1 and PC2 are in this blue region, will be predicted to belong to customer segment number 3. Then this is the prediction region of customer segment number 2, where all the wines for which the PC1 and PC2 extracted features that fall in this green region will be predicted to belong to customer segment number 2. And finally, this prediction region, red, corresponds to customer segment number 1, inside which all the wines of which the extracted features PC1 and PC2 fall in this region will be predicted to belong to customer segment number 1. All right, and then of course all the dots here, the green dots here, the blue dots here, and the red dots here are the real observations, the real wines themselves of the training set. And so here we can indeed see that we have a few incorrect predictions, but that's only on the training set. For example, this is a green wine, meaning a wine that belongs to customer segment number 2, which was predicted by the model to belong to customer segment number 3. And these are 2 other incorrect predictions of wines that belong in reality to customer segment number 2, but were predicted by the model to belong to customer segment number 1. All right, and then another incorrect predictions here. But to look at the incorrect predictions, it's more interesting to check them out on the test set. And here is the test set. And indeed, even on new observations, our logistic regression model combined to dimensionality reduction was perfectly able to separate well the 3 classes. And we can see very well that, incorrect prediction that we saw here in the confusion matrix, which is, right here, that's the incorrect prediction, and it corresponds to a green wine, meaning a wine that in reality belongs to customer segment number 2, but was predicted by the model to belong to customer segment number 1. But that's okay, any business owner or data scientist that ends up with such result with only one incorrect prediction can just be super happy. But let's see if we can beat that with our other dimensionality reduction techniques like linear discriminant analysis. And, to beat that, we'll have to simply get a 100% accuracy. So we'll see if, the linear discriminants, which are the extracted features of the LDA technique, can build, a prediction boundary that can separate well all these three classes. So this will be quite challenging, but this is doable. And then we'll check if we can also do the same with kernel PCA, which is our final dimensionality reduction technique. All right, so as soon as you're ready for the next technique, well, I'll be super happy to join you in the next practical activity to implement LDA. And until then, enjoy machine learning.